Greetings. Welcome to the lecture number 4 of infinite series. In that series, till now we have learned the concept of infinite series, comparison test, some technique to find if whether a series converges or diverges. Also, we have learned the concept of convergence series, divergence series, and mm, the oscillatory series. Particularly in that lesson, we will find out the two more technique to find a series whether it is converges or not. These two techniques are called root test and integral test. Let's start. Let's have another technique to find a series convergent or divergent. Okay, this technique we call Cauchy's root test. What is the statement of this technique? Suppose we have an infinite series that called un. We have to find that this whether this series is convergent or divergent. To find this, we have to find a value of this p that limit n tends to infinity root 10 of this un. Okay, if we find this terms, this value of p, we'll find that series convergent or divergent. How? If the value of this p is greater than 1, then the series will be convergent, and then the series will be called convergent, gnt. If that value of p is greater than 1, then the series is divergent. And in case if the value of p is equal to 1, then the series will call, the test will call inconclusive. That means that we are not getting anything from this test. So the test, basically the test, that means the test fail. fail, that means the test fail. Okay, now find an example to let's have an example to find whether this test works or not. We have to, here we are an example, we have to find that with this series whether it is convergent or not. Okay, and we'll use that Cauchy's root test. How? First, we define this un is equal to 1 by l log n to the power n. Okay, now what will be the term p? That term limit n tends to infinite 1 by root root n of 1 by log n to the power n. That means that means that limit n tends to infinity 1 by log n. Now these terms, look at this term, for n tends to infinity these terms will be 0, as this the value of p is 0, that is less than 1. So this series is convergent. So the series can be called convergent. Okay, is, do you still have any doubts? You can comment your doubt. Let's find another test to find a series whether it is convergent or divergent. This series is called Cauchy's or maclaurin integral test. To learn the series, let's start what this series actually state. If we have any continuous monotonic decreasing function of like fx is a continuous monotonic decreasing function, in which that fx actually means un, then to find the series converges or diverges, we have to find that integral of from 1 to infinite fx dx, the value of this term. If the value of this term is finite, then that infinite series will be called converges, or otherwise that series will be called diverges, right? So the concept of the Cauchy's or maclaurin integral test, or somebody also says that is only integral test. That is concept if we have an monotonic decreasing function fx, and that will that is look like that, then we can find the integration of that fx dx, and if we get that integration value of integration finite, then it is converges, and if not, then it is diverges. And the value of this one is the lowest number of on that terms, lowest number of terms of that series is 1. If the lowest number of term of the series is not 1, suppose it is say the lowest number is 3, then it can be written as 3. If it is 5, then it can be written as 5, whatever it is. So let's take an example on of it. Suppose a series, we have a very basic series, 1 by 2 square plus 1 by 3 square plus dot dot dot. This is a series we have. Okay, now to find that series whether it is convergent or divergent, we use the Cauchy's integral test. How we will use? Let's first find out the function. That function will be look like n square. This, that is the function look like, and we say this function is as fn. Now to find the, we need to find the value of what is the lowest term, that one. So it is 1, and it is infinite 1 by n square dn is the value. For this, what will be the value of this term? 1 by n square dn. The value of this integral is 1 by n minus the from 1 to infinity, 1 to infinity. The value of 1 by infinity is 0, so the total terms will be 1. It has a finite value. This is a finite value. As it is a finite value, then the series is, we can say that therefore the series is convergent. Series is convergent. So there in the series is convergent. I hope everyone have cleared all the concept. If anyone have any doubt, you can ask. There should be no hesitation to ask a question, and for your convenience, the study materials is attached in the description box. Thank you.